Good evening, all. Padimalar Institute of Technology, ASTE Prerana sponsored GATE training program. Subject Engineering Mathematics, topics Calculus. So, Calculus include differential calculus as well as integral calculus. GATE exam point of view, we are going to discuss. So, for this, initially some definitions and hints, then GATE questions we will discuss. So in the calculus, in the beginning, we'll take it up limits and continuity. So limit of the function and continuity of the function. So limit of the function, a function f of x is said to be have a limit value t as x tends to a if limit x tends to a f of x equal to L. So in the function, when you substitute x by a, you will get some constant value that is called the L. So we all basic things. So firstly, we move on. So left limit. So when x less than a, x tends to a can be denoted like this. A little bit different ways. Some of authors may mention that is instead of x replaced by a minus h. Left limit as a minus h. Right limit as a plus h, where h is a very small value near to 0. Like that they will take. So here simply we take it up as a limit x tends to a minus. Okay, from a minus we approach the limit. F of x limit a tends to 0, that is sorry, h tends to 0, f of a minus h, very small value h, like that we take. So the right limit, that is x greater than a, where x greater than 0, limit x tends to a plus f of x equal to that limit x tends to 0, f of a plus h. In that function, it replaced by f of a plus h. A limit exists of these cases. If limit exists, then left hand limit is equal to right hand limit. LHS equal to RHS. Okay, it's not always same. Will get some other function may differ. So, for example, one example is given: f of x equal to 2x plus 3 for x greater than 2, x plus 9. I mean step function. It's called as the step function for x less than 2. So then limit x tends to 2 will get the value as a 7. If x less than 2, the function is x plus 9. That is in the form of x tends to 2 minus. So that is 11. So the given f of x is called the step function. Okay, so that is x greater than or equal to 2. The function is 2x plus 3. X less than 2, that is x plus 9. So when you apply the limit at a equal to 2, for 2 plus, the value is 7. For 2 minus, the value is 11. So hence, for this function, limit does not exist. Standard limits, like a formula, we have to remember. So there is limit x tends to a, x power n minus a power n by x minus a equal to n into a power n minus 1. Limit x tends to 0, x power mx minus 1 divided by x is equal to e. Okay, e power 1. I mean the constant e power 1 when you substitute x by 0. Third one, limit x tends to 0, e power x minus 1 divided by x, that is log base e value constant a. Okay, so that is limit x tends to 0, that is a power x minus 1 divided by x, that is log base e, like we'll get it. So that is limit x tends to 0, 1 plus ax whole power 1 by x is equal to e power a. Next one, limit x tends to 0, 1 plus a by x power whole power x equal to e power a. Next one, not visible in my screen. Okay. Right hand side, that is limit x tends to infinity, limit x tends to infinity, sin x by x equal to 0. Next one, standard one, limit x tends to 0, sin mx by x equal to m. Otherwise, limit x tends to 0, sin x by x equal to 1. In some problems, we use limit x tends to 0, sin x by x equal to 1. So keep it as a formula. Next, limit x tends to 0, a power x plus b power x divided by 2 whole power 1 by x equal to root ab. Next, limit x tends to 0, cos x plus a sine bx whole power 1 by x, that is e power ab. Limit x tends to 0, 1 minus cos ax by x square is equal to a square by 2. So in the screen, if it is visible, go through that also formula. This all we have come across in the lower classes. Do remember, recall those things as a formula. And the corresponding explanation already given, I mean, it's there. But in the exam point of view, concentrate these things as a formula. Do remember this formula. Limit properties, limit extends to a, c into f of x. C, take it outside as a common, limit extends to a, f of x. Next, limit extends to a, f of x plus or minus g of x. So limit extends to a, f of x plus or minus limit extends to a, g of x. Okay, if it is plus is there in between the function, you can apply the limit plus. If it is minus between the function, two different functions, we can apply the minus. Limit extends to a, f of x into g of x, f of x into g of x, two different functions. To apply the limit, so you can apply limit to the individual functions. So in the limit case, we can apply, okay, limit extends to a, f of x into limit extends to a into g of x. So in the division also, numerator separately limit, denominator separately, you can apply the limit. Here one more condition, limit extends to a, g of x not equal to 0. If you get 0, that entire limits become infinity. Okay, so that is wrong. So now next one, limit extends to a, f of x whole power n can be denoted as a limit extends to a, f of x whole power n. It's a real number where n is a real number. Real number means including fraction. Okay, so not only integer 1, 2, 3, 4. Not only that, 1 by 2, 3 by 2, like that values included. Limit extends to a nth root of f of x, that's equal to nth root limit extends to a f of x. Please don't switch on your mic. Ask your classmates to join. Only some 35 only join. Ask your classmates to join the class. Limit extends to a, c to c. Okay, so constant function. In that, no place to apply the limit. Okay, so these all GATE questions. GATE 2008, it seems. So limit of x tends to 0, sin x by e power x into x. What will be the value? So these kind of questions, you may get the options. So here in the GATE, you will get 1 mark question, 2 mark question, and 5 mark question. 1 and 2 mark questions, you will get objective type, and 5 mark questions, you have to answer it. I mean, you have to solve it yourself and give the correct answer. Okay, like that you will get the question. So here limit extends to 0. This is probably 1 or 2 mark question only. Sin x divided by e power x by x, limit extends to 0. Sin x by e power x into x, that is limit extends to 0. As per the property, consider like two functions, break like sin x by x, one function, other function as a 1 divided by e power x. So the first function using the formula limit extends to 0, sin x by x, that value is 1. So in the second function, apply x by 0. So that is 1 divided by e power 0. So e power 0 is 1. Okay, 1 by 1, that is 1. Okay, 1 into 1, that's equal to 1. E power 0 not equal to 0. E power minus infinity is the 0. E power plus infinity is infinity. Okay, you should not get such a case. E power plus infinity equal to infinity. E power minus infinity equal to 0. E power 0 equal to 1. So do remember those values. Next one, limit n tends to infinity 1 minus 1 by n 2n, okay, power 2n. Here also they have applied the property. So that is 1 minus 1 by n, take whole power 2, whole power 2, square like you have applied it. So the inside functions, break it in between the minus, take it to the second value as a minus. So convert as a 1 plus of minus 1 by n. So that is 1 plus inside the bracket minus 1 divided by n whole power 2. So that is inside using the value of function 1 plus 1 by x, that is equal to e power x, but here x is not there, that is as a 1 we have, so we can mention it as a e power minus 1. E power minus 1 is equal to 1 plus minus 1 by n whole power n is the function. So the numerator you may get 1 plus inside the bracket minus x by n can be denoted as a e power minus x. That's a formula. Using that here, instead of x we have minus 1. Replace it, you'll get as a e power minus 1 whole square, you'll get it. That is multiply 2 into minus 1, you'll get as a e power minus 2 will get. Next one, another gate question, that is limit extends to infinity, x minus sin x divided by x plus cos x. For that, numerator take it up x as a common, denominator also x as a common. Okay, so when you take numerator x as a common, it's become as a 1 minus sin x by x. Denominator x take outside, numerator whole numerator x divided by denominator x getting cancelled, then you will get like this 1 plus of cos x by x, numerator 1 minus sin x by x. So in that limit constant function, you'll get same constant, so because we cannot apply limit to the constant, so numerator denominator form. So that is in the numerator, when you apply limit x tends to infinity sin x by x, denominator cos x by x will get that is x tends to infinity. Okay, so when you apply it x tends to infinity sin x by x, you will get 0. Limit is not 0, it is limit is infinity. So for infinity 0. So similarly for cos x by x also, when you apply the limit x tends to infinity, the value is 0. So that is 1 minus 0 divided by 1 plus 0 equal to 1. Here no place to apply the L'Hospital rule. So next one is limit x tends to infinity, x power root 3 minus 2 divided by x minus 8. Yes, now you can see fully. Okay, so that is x tends to 8, not infinity. Okay, so there is x power 1 by 3 minus 2 divided by x minus 8. Okay, it's not visible properly, sorry. So limit x tends to 8, x power 1 by 3 minus 8 power 1 by 3 divided by x minus 8. So in the numerator, the 2 can be denoted as a 8 power 1 by 3. So to make it as a common value, okay, power 1 by 3, that is 8 power 1 by 3. Okay, cube root of 8 is nothing but 8, sorry, 2. Okay, cube root of 8 is 2. Okay, so 2 into 2, 2 into 2 into 2. So that means 3 times multiply, you will get 8. So the 8 you can write as a 2 power 3 whole power 1 by 3. So finally you get the previous value 2. Okay, so that is formula limit x tends to a, x power n minus a power n divided by x minus a is equal to n into a power n minus 1. So using that here, n equal to 1 by 3. So replacing that value as per that formula, you will get 1 by 3 into 8 into 1 by 3 minus 1. So you will get as a 1 by 3 into 8 power minus 2 by 3. So 8 power minus 2 by 3, it is there in the numerator. Take 8 to the denominator, that power minus become as a plus. So 8 power 2 by 3, positive 2 by 3, that is equal to 4. Got it? 8 you can write as a 2 power 3. Okay, this 8 can be first step. You take this 8 power minus 2 by 3 to denominator. This power minus becomes plus. Then next step, make it 8 as a 2 power 3 into power 2 by 3. So the 3 getting cancelled, you will get 2 power 2 will get. That's why they have put as a 4. So prior value 1 by 3 as it is. So you will get as a 1 by 12. Okay, so carefully you have to apply, looking simple without knowing those properties and formulas, standard formulas, so we cannot solve these problems. So a few more limit problems. Find limit t tends to 0, root of t square plus 9 divided by t square minus 3. Okay, whole divided by t square. Minus 3 is a numerator. Include the denominator values t square. So that is limit t tends to 0, t square plus 9 minus 3 by t square. Straight away when you apply it, we may not get any value. So that is denominator t by 0 as a 0. Instead of t, this may be asked in the form of x also. So for this, using the value, multiply and divide that root of t square minus plus 9 plus 3. Okay, consider like x minus a. So that is multiply as a x plus a into x plus a to get some meaningful value. So that's why we are taking like this. So that is numerator, this root of t square 9. Okay, so that is a minus b into a plus b will be there in the numerator. So a equal to what? Root of t square plus 9. So for that the square is become as a t square plus 9. Root vanish, you'll get as a t square plus 9. So that minus d square. So 3 square is a 9. That's what they have put as a 9. So t square plus 9 minus 9, the numerator, denominator to different value only. So that is t square, root of t square plus 9 plus 3. So we can eliminate numerator, that 9 getting cancelled, only t square. The denominator t square into root of t square plus 9 plus 3, like we are getting. So hence we can eliminate the numerator t square and the denominator t square. Now we can apply the limit t tends to 0. When you getting cancelled numerator t square, it's become as a 1, not 0. Okay, careful. That is value 1 in the numerator, not 0. So here inside root, the denominator, t tends to 0. So 0 plus 9 outside the root 3. So that is 3 plus 3 is 6. Okay, in the denominator you will get 6. So that is 1 by 6 will be the value. So when you apply the value directly, t tends to 0, you will get value 0. You will not get any proper or finite value. Okay. So now, next problem. This is also great question. Okay, limit x tends to 0. Modulus of x by x does not exist. Whether it exists or not, two options given. So in that, whether roots exist. Okay, otherwise they may give different root. I mean, different limits. Okay, different limits. Whether it exists, does not exist. Limit exists in between 1 to 0, in between 0 to -1. Like they may give for different option. So we have to choose and check whether the limit exists or not. So f of x equal to modulus of x by x. So modulus of x is the function. It will take negative value in the negative interval, positive value in the positive interval. Okay, so that means if you consider the axis, that is in the limit 0, 1, 2, 3, 4. In that area, modulus of x will takes a positive value. If x takes a negative value, I mean in the negative interval, left side interval, so see that diagram, there you will get a negative value. So here you have to go for whether the limit exists or not. So here at point x tends to 0. So f of x is what? Modulus of x by x. So first they take it up right side limit, that means 0 plus. So 0 plus right side limit where x tends to 0. So that means for x equal to 0 right side, you will get 1, 2, 3, like positive values will get. So modulus of x becomes simply x. So here when you put value 0, 0, what you will get? 0 by 0 will get, what is that? Applying the, I mean, indefinite form, apply the L Hospital rules, numerator, denominator, separately differentiate, you will get value 1. So hence, for that case, value is 1. Okay. So next one, for the left side limit, that is limit extends to 0 minus, that is a function f of x, 0 minus for modulus of x, negative value will take. So modulus of x equal to minus x, denominator x as it is. So again, indefinite form will get it. Again, differentiate numerator separately, denominator separately. Numerator minus 1, denominator plus 1. So hence, for this, the value is minus 1. So LHS not equal to right RHS. That means left side limit not equal to right hand side limit. Okay, left hand side limit is plus 1. Sorry, left hand side limit is minus 1. Right hand side limit is plus 1. So hence, limit does not exist. Okay, limit does not exist. So next one, find the maximum minimum value of the function. So limits over, limits problems over. So remaining problems, you can check it. Similar way you can apply it. So for that, you need properties and standard formulas. Okay. So we have discussed some of the problems which asked already in the GATE exam. So now move on to the next problem. Find the maximum and the minimum value of the function. Maximum minimum of the function. So y is equal to x minus 2 whole square into x minus 3. Otherwise, there's that x minus 2 square into x minus 3. I mean, y or f of x. Both we can take it up. So apply the maximum minima concept. Okay, maximum or minimum value of the function. So for that, applying the procedure, that is first we have to find point, extreme point. Okay, first we have to identify the extreme point. After that, at which point it takes the maximum value or minimum value. So in that procedure, we applied. So now y or f of x both same. Okay, so take it up as a y if given function is as a f of x. Take it up as a y. First differentiate. First differentiation dy by dx. Ordinary differentiation here it is in the multiplication. I mean two function in the multiplication. X minus 2 whole square into x minus 3. Okay, not in between plus. If it is plus, directly you can differentiate. But two different function in the multiplication. Okay, so apply UV formula, product rule, apply it. Okay, otherwise you can expand x minus 2 whole square and multiply with x minus 3 and proceed. So that is one way, but as it is, we can keep the function and differentiate like UV method. First function u is equal to x minus 2 whole square, v as a x minus 3, like you can take it up. So first keep it up, first function as a constant, second function x minus 3, differentiate with respect to x. So that is x minus 3 equal to differentiation 1. Next, differentiate the first function x minus 3 as a constant. So that is the first function x minus 2 whole square, differentiate 2 times of x minus 2 into derivative inside function with respect to x. That's equal to 1 will get. Next, x minus 2, take it outside, then you'll get as a x minus 2 plus 2 into x minus 3. Why we have to take like this? So we have to equate first derivative to identify them extreme points. That is the concept. Okay, so basic some of the problems we use some different concept logic. So here for this is the procedure. Anyhow, first derivative at the extreme points, first derivative equal to 0. To find the extreme points, first derivative identify and equate to 0 to identify the extreme points. So hence take like this. So x minus 2, that inside function to multiply, you will get as a x minus 2 into 3x minus 8 will get. Now equate the first derivative to 0, that is x minus 2 into 3x minus 8 equal to 0. So factor form, that is x minus 2 equal to 0, you'll get x equal to 2. Next one, 3x minus 8 equal to 0, that is 8 to the right hand side, and x equal to 8 by 3. Another point is 8 by 3. x equal to 2 and x equal to 8 by 3, two extreme points we are getting. We have to check at which point it is going to be maximum value or minimum value. Sometimes we may get both the points are equal value. Okay, so that's also. So now check it in the secondary derivative, find the secondary derivative. The function is x minus 2 into 3x minus 8. So dy by dx equal to above 1, we use it as a x minus 2 into 3x minus 8. This one differentiate once again. That is a secondary derivative. You will get as a x minus 2 into 3 plus 3x minus 8. That means again UV method. Keep x minus 2 as a constant. Differentiate 3x minus 8 with respect to x. So 3x as a 3, 8 constant, differentiate 0. Plus 3x minus 8 as a constant, x minus 2 differentiate, you will get value 1. Now multiply that 3 inside and here 1 inside, you will get as a 6x minus 14. 6x minus 14. So now at the point 2, what will be the value? If it is less than 0, f of x is maximum. If it is greater than 0, that is minimum. So when you apply it, 6x minus 14, secondary derivative at the point x equal to 2, we are getting negative value. So hence f of x is maximum at the point x equal to 2. So secondary derivative is a negative value. If we get it at that point, f of x takes a maximum value. That is a concept. So that is after verify whether the point is maximum or minimum. So here x equal to 2 is the maximum point. Hence substitute 2 in the function. We are getting maximum value as a y equal to 0. Okay, in this problem we are getting that is also some value. Okay, don't think it is 0 is the not maximum like that, but the value some constant we are getting. Okay, next point x equal to 8 by 3, substitute in the function, we are getting which one? Secondary derivative. When you apply it, we are getting greater than 0. So x will be the minimum value. So that is a substitute it in the function. 6 into 8 by 3 minus 14, we are getting as a 4 greater than 0. So f has minimum at the point x equal to 8 by 3. So substitute it in the function x minus 2 into x minus 3. So that is 8 by 3 minus 2 whole square into 8 by 3 minus 3. So that is x, that first one take LCM, you will get as a 2 by 3. The second one take LCM as a 3, you will get as a minus 1 by 3. First one 2 by 3 whole square as a 4 by 9. Second one is negative, so hence minus 4 by 27. So the minimum value is minus 4 by 27 at the point x equal to 8 by 3. Okay, so compare with the maximum value. Maximum value is 0, minimum value is minus 4 by 27 for this function. Okay, so clearly understood. First, x equal to 2 is the maximum point, x equal to 8 by 3 is the minimum point. This is also maximum, minimum, but in the particular interval we have to check. So consider the function f of x equal to x square minus x minus 2. The maximum value of f of x in the closed interval minus 4 to 4. So that means include minus 4 to plus 4. That means minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. In those values, we have to check. These are the values options. Okay, 18, 10, minus 2.25, and intermediate. What will be the maximum value of the function in that interval? So first we have to identify the extreme points. So for that, first derivative we have to identify f dash of x, partial differentiate with respect to x, single variable. So that is 2x minus 1 will get equate to 0. We are getting only one value, that is x equal to 1 by 2. Next, identify secondary derivative. Secondary derivative we are getting as a greater than 0. Okay, because differentiate first derivative 2x minus 1 with respect to x once again. So 2x as a 2 minus 1 with respect to x 0. So that means 2. So the value is what? Greater than 0. So as per the prior concept, second derivative greater than 0 means the point is minimum point. Okay, if second derivative is less than 0, the point will be maximum. Okay, so hence x equal to 1 by 2 is the minimum point. So that 1 by 2 point is lies inside the interval. So in that interval, at which point it takes the maximum value or minimum value. So in that we have to check it in the endpoints in the function. So find the endpoint values. So that is f of 4, f of minus 4. That is plus 16 become as a plus 4x. Okay, so that means what? 16 plus 4, so plus 20 minus 2. So you will get as a 18 for f of minus 4. So ordinary number substitution only. Then at x equal to 4, first one you will get 16 minus 4 minus 2. Okay, so 2 minus value. So minus 4 minus 2 as a minus 6. First one 4 square is a 16. 16 minus 6, so 10. Okay, so here at which point it takes the maximum value? At x equal to minus 4, it takes the maximum value. They are asking maximum value of f of x. Okay, maximum value of f of x. So hence suitable value is 18. This all taken in the previous GET question papers. The minimum point of the function f of x equal to x square by 3 minus x is at x equal to 1, x equal to minus 1, and x equal to 0, and x equal to 1 by root 3. The minimum point of the function. They are asking minimum point. Previous problem, maximum value at particular interval. Okay. First, we have to identify the extreme points. Then we have to check at which point it takes the minimum value. So we have to identify what is the minimum point. So first, we have to identify the extreme points. To find the extreme point, find the derivative, first derivative. First derivative, x square by 3 minus x. So x square as a 2x, denominator 3 as it is, minus x as a minus 1. Differentiate minus x as a minus 1. That is given in the fifth line, okay, where I kept the cursor. Next, equate f dash of x to 0 to identify the extreme points. Extreme points means it's include maximum point as well as minimum point. Okay, sometimes you may get the saddle point. Saddle point is nothing but it's not maximum nor minimum. It's not not a maximum, not a minimum. Such a point. Some points, okay, but it will be a extreme point. Okay, some of the case you may get some points as extreme point, but it's neither maximum nor minimum. Okay, so that is equating first one to the 0. 2x by 3 minus 1 to 0. So 2x by 3 equal to 1. Then x equal to 3 by 2 will get. Okay. So manually you can calculate, take the minus 1 to the right hand side. So you'll get a 2x whole divided by 3 equal to 1. And apply the cross multiplication to get the x value. So that is x equal to 3 by 2 will get. Now whether the point is maximum point or minimum point, we are getting only one extreme point. For this case also only one point, x equal to 3 by 2. Okay. So whether the point is maximum point or minimum point, we have to check. That is f double dash of x. First we have to find the f double dash of x, we have to identify. So first derivative, once again differentiate. So 2x by 3, that means 2 by 3 constant. set is keep it x differentiate, you will get value 1. That -1 separately differentiate with respect to x, that is 0. So you will get the pure the constant 2 by 3. Anyhow, that 2 by 3 is positive number greater than 0. So as per the concept, the point is minimum point. Point is x equal to 3 by 2. So f double dash is we are getting positive value. So the point is what? 3 by 2. So here near to some of the points they have mentioned at which point the function takes maximum value or minimum value. So for f of 1, when you replace it, we are getting it as a minus 2 by 3. How come? So 1 by 3 minus 1 will get, then take LCM as a 3. Okay, 1 by 3 minus 1. So that is 1 minus 3. 1 into 3 take as a LCM, multiply 3. So in the numerator, 1 minus 3 whole divided by 3. It is minus 2 by 3 will get. Next for f of minus 1, that is 1 square by 3. So anyway, plus 1 by 3 minus we are getting 1. That means minus x by minus 1. Minus or minus plus will get. So that's why the value is 4 by 3. Okay, that's why we are getting the value is 4 by 3. Okay. So next for f of 0, in both the terms x is 0. So we will get a value also 0. And next f of 1 by root 3, some positive value, at which point it takes the, which is going to be the minimum point. So x equal to 1 is the minimum point. Okay, so see that in 4 points given in the option, substitute it in the function, first one negative value, remaining 3 values are positive. Okay, third one 0 is a 0, consider like a positive value. So anyway, next 3 values are some positive value, but for the f of 1 we are getting negative value. So hence that point is the minimum point. This one also asked in the 2 mark question. The function f of x comma y, I mean get 2 mark question. F of x comma y equal to 2x square plus 2xy minus y cube has only one stationary point at 0 comma 0. Two stationary point 0 comma 0 and 1 by 6 comma minus 1 by 3. Two stationary points at 0 comma 0 and 1 comma minus 1. Here it's like coordinate form it is given xy. Okay, xy, two variables function. Okay, stationary means extreme points. Okay, indirectly they are mentioned nothing but the extreme points only. So for that we have to apply the concept for the two variable. For this, first to find the fx, partial derivative fx fya, and equate to 0. Combinatorily identify the extreme points. Based on the extreme points, we have to check. I mean here what are the extreme points we are going to get for this function, given function. Okay, they have asked simply the maxima or minima, it will be 5 mark question. It will take time. But here they have asked only the extreme points. That means the stationary points. As per the options, 0, 0 or 0, 0, 1 by 6 minus 1 by 3. Otherwise, 1 comma minus 1 and 0, 0. No stationary point. These are the possible cases like that they are telling. So we have to check. Okay. So that is first, this concept is first derivative with respect to x, y, we have to identify and equate to 0. So all those equation, fx and fy, identify the value of x and y. Those things are called the extreme points, I mean stationary points. Okay, for that enough. So first fx, partial differentiation with respect to x, for that y as a constant. So 2x square. So 2 into x square as a 2x. So that is 4x will get 2xy for that 2y as a constant, x differentiate value 1. So with respect to x partially, y cube is constant, so 0. That's why we are getting fx. Sorry. Okay, 4x plus 2y we are getting. Next, fy, partial differentiation with respect to y. For that, x is constant, so 0. So that is 2x square with respect to y partially 0. For 2xy, 2x as a constant, y differentiate, you will get value 1. That's why they are putting as a 2x only for 2xy differentiation. Next, y cube as a 3y square. So that's in the partial differentiation. Equate fx and fy to 0 to identify the stationary points. So first one is 4x plus 2y equal to 0. Another one 2x minus 3y square. 3y square equal to 0. Put 2x equal to 2x equal to 3y square in the first equation. So separately you cannot identify the points. So here by substituting from the second equation, substituting the first equation, solve that, you will get the points value of x and y. So in the place of 2x, replace 3y square in the first equation. The first equation we have 4x. So 2 times of this value, when you put it, 6y square will get. In the place of 4x, replace 2 into 2x. Okay, the 4x we can write as a 2 into 2x. So 2 into for 2x as a 3y square. That's why they have put as a 6y square. So 6y square plus 2y equal to 0. Further, the constant part, whole equation divided by 2, you'll get 3y square plus y equal to 0. Take y as a common. So here no constant term, 3y square plus y equal to 0. If constant term is 0, some constant term is there, second order equation, factorization format we have to use. Here constant term is 0, so hence you can take y as a common. Okay, so that is when you take y as a common, remaining value 3y plus 1 equal to 0. So first one y into 3y plus 1. So y equal to 0, one of the value of x, another one 3y plus 1 equal to 0. So 3y equal to minus 1. So y equal to minus 1 by 3. So y value 0 and y equal to minus 1 by 3, substituted in the relationship. Okay. Substituted in the relationship 2x equal to 3y square, you will get x value. Okay, x equal to 0. So that means 2x equal to 3y square, x equal to 3 by 2 into y square. So x equal to 3 by 2, y value 0. So hence x value also 0. So now 3 by 2 into y equal to minus 1 by 3. So that means minus 1 by 9. Simplify, you will get value 1 by 6. So make it as a coordinate form. When you substitute x equal to 0, we are getting y equal to 0. So 0, 0, 1 point. Another one, 1 by 6, comma, minus 1 by 3. X value as a first value. So it is a second case. Okay, for this case, two stationary points will get 0, comma 0 and 1 by 6, comma, minus 1 by 3. If they have asked in the question, at which point it takes a maximum value or minimum value in the 5-mark question, we can solve further. So if it is a 5-mark question, they won't give option. You have to solve manually and upload the answer. Okay. It's similar kind of problem. The optimal value f of x comma y equal to 4x square plus 6y square minus 8x minus 4y plus 8 is a minimum equal to 10 by 3, is a maximum equal to 10 by 3, is a minimum equal to 8 by 3, is a maximum equal to 8 by 3. We have to check at which point it takes a maximum or minimum, which value, which option is a suitable one. So the explanation, two variable function. So partial differentiate with respect to x, please do follow. Okay, so the problem hints only given, not to elaborately mention, but do follow, you can understand. Anyhow, these are standard problems. Okay, so that is a partial differentiate with respect to x. With respect to x, y as a constant. So 4x square as a 8x, 6x square, 6y square with respect to x 0, minus 8x as a minus 8. The remaining terms are no x, it's a pure constant, so 0. So fx equal to 8x minus 8. Next, fy, partial differentiation with respect to y. In the second and fourth term, we have y. So 6y square as a 12y minus 4y as a 4, partial differentiation with respect to y. Other values are 0 with respect to y, partially. we have to identify the stationary points or extreme points to equate fx and fy to 0. So fx to 0, you will get 8x minus 8 equal to 0. So x equal to 1, we are getting. Second one, 12y minus 4, that is equal to 0. So we are getting y equal to 1 by 3. So here the two variable function, when you combine it, that is 1 comma 1 by 3. Okay, there is no substitution. We are getting only one extreme points for this function. 1 comma 1 by 3 is the extreme points. Next, at which point it takes a maximum value. These cases consist three cases. Fxx, second derivative with respect to x, y, we have to identify. So see that rt minus s square should be greater than 0, that is minimum. If rt minus s square less than 0, that is maximum. If rt minus s square equal to 0, that is a saddle point. Okay. See that fxx, that is the r. Nothing but fx once again with respect to x, partially with respect to x. So fx is 8x minus 8. Differentiate once again with respect to 8. X, you will get 8x as a 8. Next, fx with respect to y. Fx function with respect to y. So fx is equal to 8x minus 8. We have to do with respect to y. In that, no y function. So hence that is 0. That's equal to s. Next, fy function once again with respect to y, that is fyy. That is 12y differentiate, that is 12 will get, that is t. At the point, extreme point 1 comma 1 by 3, we have to check. So here in these RST all directly constant. Sometimes you may get as a function of x comma y. If possible, you can substitute this point to identify the value at that point. Okay, 1 point or 2 points. Okay, for different points, it may act as a maximum or minimum. So here rt minus s square, we have to check r equal to what? Fxx. T equal to what? Fyy. S equal to fxy. Okay. So before we substitute directly, we are getting constant. So whatever be the point, the second derivative takes as a positive. That means rt minus s square equal to positive greater than 0. If rt minus s square greater than 0 at the point, okay, this point or any point for this problem, that is going to be minimum. That is the meaning. Whatever point we are going to get, extreme point, we are going to get, that is going to be the minimum point. Okay, that is the claim we are getting while solving the problem. So hence the point is minimum point 1 comma 1 by 3. Substituted in the function f of x comma y, x by 1, y by 1 by 3. Okay, x by 1. So 4 plus 1 by 3, that is 6 by 9 minus 8 into 1 as a 8. So minus 4 by 3 plus 8. This is all there. So take it up as a LCM as a 9 and simplify. Okay, we can make it as a 3 also. Okay, so that is 6 by 9 is that we can make it as a 2 by 3 and LCM as a 3 and simplify, we'll get as a 10 by 3. So this one is minimum. Okay, it's not a maximum. 10 by 3 positive value anyway. Based on the concept, we are getting this a minimum value. Okay, so for this function at the extreme point, it takes the minimum value 10 by 3. Okay, not maximum value 10 by 3. Okay, for the function f of x equal to x square e power minus x, the maximum occurs when x is equal to 4 options 2, 1, 0, minus 1. Am I audible? Screen is visible?
Yes, sir.
Thank you. Okay, so 3 options, again same kind, but function is exponential function we are getting. So there is x square into e power minus x. Here identify the point first, extreme point. Then we have to identify what will be the maximum value. Okay, what will be the maximum value? So f dash of x here x square e power minus x. UV method we have to apply. So first differentiate x square as a 2x, e power minus x as a constant. That's what it is given. Do follow. Okay, we will continue. So f dash of x equal to differentiation UV method. 2x into e power minus x minus x square e power minus x. Okay, UV method. First differentiate x square as a 2x, keep e power minus x as a constant. Second time x square as a constant, differentiate e power minus x, that is minus e power minus x. That's what they have put here, like this. So secondary derivative we identify. So carefully you have to equate to 0 to find the extreme points. So for extreme, f dash of x equal to 0. So equate this function to 0. 2x e power minus x minus x square e power minus x equal to 0. We are getting x equal to 0 and x equal to 2. That is, take common value x, e power minus x common. Okay, so you can take it up, e power minus x as a common. We can take remaining values equal to 0. Got it? So this one 2x e power minus x square e power minus x. In that, take common x e power minus x common. The first term 2, remaining second one as a x will get. Okay. For first one, you will get x equal to 0. Second one,
x is equal to 2.
okay. You need explanation, otherwise we can explain in the paint. Here I cannot write. Okay, understood. Okay, fine. So we'll move on. So we take it up the 2 points, x equal to 0 and x equal to 2. Okay, in that 2 points, substitute. I mean, before go to identify whether these points are maximum point or minimum point, we need a secondary derivative. Then only we can check whether the point is maximum point or minimum point. Then we have to substitute it in the function to identify maximum value. Okay, so here we have to identify the secondary derivative. F dash of x is 2x e power minus x minus x square e power minus x. Okay, 2 UV method we have to apply. So first term 2x e power minus x in the form of UV method when you apply it. So 2 differentiate x as a 1 first term by where I kept the cursor, please do follow, into e power minus x. Next minus 2x, I mean 2x plus 2x, differentiate e power minus x, you will get minus. Okay, 2x as a constant, differentiate e power minus x, you will get minus e power minus x. That's why here in the second term they are putting as a minus. Okay. So next minus as a common, x square differentiate as a 2x into e power minus x as a common. Next minus x square, keep it as a constant. E power minus x differentiate, you'll get one more minus will get. That's why the fourth term as a plus we are getting. So x square into e power minus x we are getting. So 2 e power minus x minus 4x e power minus x plus x square e power minus x. This is a second derivative function. So we have to check for x equal to 0 and x equal to 2. Second derivative value at the second derivative. Second derivative at the extreme point. So when you substitute x equal to 0 in that function, e power minus 0 or plus 0, both same meaning, that is value 1. Okay, e power 0 is 1. E power minus 0 or plus 0, that is nothing but e power 0 only. So first one is 2, second one 4 into 0, so e power whatever it may be, so it's become as a 0. Next one x is there, so 0. So hence we are getting 2. So f double dash of x at x equal to 0 is nothing but 2. So in the second derivative, replace x by 0. So 2 e power 0 minus 4 into 0 plus x is means 0 into e power minus x. So you'll get as a 2. So now substitute x equal to 2. So 2 e power minus 2 minus 4 into 2, that is minus 8 to e power minus 2 plus 2 square is 4 e power minus 2. So all terms e power minus 2 exist. First one 2 times of e power minus 2. Next one 8 minus 8 times of e power minus 2. Next one is 4 times plus 4 times of e power minus 2. First and last positive value. So 6 times of e power minus 2. Middle one is minus 8 times of e power minus 2. So hence we'll get minus 2 e power minus 2. Okay, minus 2 e power minus 2 will get here for e power minus 2 positive value will get. Okay, you can check in the calculator. In the front side we have negative, so anyway we are getting negative value. So see if second derivative is negative value, at that point it takes a maximum value. So first point, that is x equal to 0 is the minimum point. Second, x equal to 2 is the maximum point, because x double dash of x at that point takes a negative value. So therefore x equal to 2 has a maximum value. Okay, they are asking the points. Okay, they are asking the point only. Okay, so hence at the value x equal to 2, it takes the maximum value. Okay, a cubic polynomial with real coefficient can possibly no extremum and no zero crossings, may have up to 3 extremum and up to 2 zero crossings. Next, you cannot have more than 2 extremum and more than 3 zero crossings. Will always have on equal number of extremum and zero crossings. A cubic polynomial, the function f of x, we have to check which one is the suitable. So f of x equal to ax cube plus bx square plus ex plus d. For this, take it up first derivative, identify the first derivative. That is f of x equal to 3 times of capital A into x square plus 2bx plus c with respect to x. The first derivative, they take it as a capital F of x. The second derivative for small f of x, it's as a capital F dash of x. To identify the crossings and the extreme points. So f dash of x is equal to 6ax. I mean 3ax square differentiate, you will get 6ax plus 2b. Once again, when you differentiate, I will get as a 6a. Next, once again differentiate, you will get value 0. So that means how many derivatives? Two extremum, because first derivative is x square. Okay, so that is 2 extremum. At which derivative? From that, which derivative it takes the 0. So based on that, we can conclude. First derivative is nothing but capital F of x. So what is that equation? Second degree equation. For second degree equation, we should get 2 points. So hence 2 extreme. Okay, as per the concept, 2 extreme points. 3ax square plus 2bx plus c. Instead of capital ABC, some constant, this capital F of x equal to 0, you will get 2 points. That is 2 extremum or 2 stationary points. Next, how come you conclude as a 3 0? That is based on the concept capital F dash, capital F double dash capital F triple dash. So at which derivative it's become as a zero. So if it is a fourth case becomes zero, we will have four zero crossings. Zero crossings will get. I mean, while drawing the diagrams, it will reach the four times passing through that zero. I mean, axis. Okay, passing through the axis. That is the meaning. Thank you. Do you have any doubt?
No, sir.